Friends, let us discuss an important topic in the course of computer integrated manufacturing is automated guided vehicles, popularly known as AGVs. AGVs are used as primary material handling devices in automated manufacturing systems like FMS, flexible manufacturing systems, and any other automated manufacturing system. AGVs are considerably used. Let us discuss what is this AGV, how was it developed, and what are the types of AGVs and further classification of AGVs, and what are the steering and guiding mechanisms of automated guided vehicles. Let us discuss these things in detail in the coming course of time. Automated guided vehicles, primarily they are material handling devices. They are used as primary material handling devices, in particularly in a CIM environment or an FMS environment. The transportation of the parts between the machines is done by automated guided vehicles or any other material handling system. From the machines to the material handling systems, or from the material handling system to the vicinity of the machine, if any other material handling system is used, that is called as secondary material handling system being used. Normally in an FMS, AGV is used to transport the parts between the machines, and AGV carries the parts. The parts are loaded from the AGV to the machine, and parts are unloaded from the machine to the AGV by another material handling system or unit, which is called as secondary material handling system. For example, normally robots will play an important role here. Robots are used in FMS environment where the parts are transported from the conveyor belt to the machines and unloaded from the machine to the conveyor belt. The conveyor belt used in FMS environment is primary material handling device. The robot that is used in this system is called as secondary material handling device. Let us discuss first of all what are all the functions of a material handling device or material handling system being used in any manufacturing unit, because what are all the qualities, how we have to design a material handling system. Let us discuss in detail. Material handling system is an integrated system that involves handling, storing and controlling materials. Material handling cost component may vary sometimes from 10% to 80% of the total costs. In certain manufacturing systems it costs more, in certain manufacturing systems it costs less. As a sim engineer, as an engineer that you are studying this subject, you are supposed to devise a method of material transportation system that costs less. That is the objective of this of us. And let us see that material handling system have to be designed under several constraints. What are those constraints? One constraint is space, the other constraint is load, capacity, cost and operating time. And let us discuss some of the important principles of material handling system. They are: one is orientation principle, that is study the system relationships thoroughly prior to primary planning. We must have to thoroughly study the relationships among the various transportation places and other things before we do the planning. Planning principle: establish a plan, that is where to where the material handling is to be connected, from which machine tool, which place or which resource to another machine or a place or resource is to be connected. What are all? Is it a direct connection or any interface is there? All these things are need to be studied by us. This is a planning principle. System principle: integrated the handling and storage activities. Normally, handling is always associated with the storage. Material storage in temporary places, or loading and unloading place, which is the raw material is loaded at one place and finished product is unloaded at one place. Maybe sometimes these loading and unloading places, both of them may be same, but you need to know where is the loading point, where is the unloading point, and are there any buffer stocks which are available in between the places, because sometimes the material transfer from one place to other place is done and material may be kept there for getting processed on another machine. So material sometimes is waiting for getting processed on a particular resource and it is under waiting time. So it is in a semi-finished product which is waiting to get processed on another machine or a resource. So sometimes in intermediate material storage locations are also to be determined. That's why the transportation and storage are very much linked activities, and these are need to be designed. Unit load principle: handle product in a large unit load as practicable, because you cannot divide a bigger quantity into small quantities as unit loads. To the capacity of the transportation system, you must have to make the bunch of the material as an unit, and the entire unit need to be transferred, and this is called as unit load, and unit load transfer principle comes under that. Space utilization principle: make utilization of all cubic space that is available. Standardization principle: standardize handling methods and equip whenever possible. You must have to standardize the part handling method and optimize the method and make it as a standard one and use it as and when it is required. Ergonomic principle: recognize human capabilities and limitations and design as per that. The human being should not get any inconvenience while transporting the material. So according to his body postures and other ergonomic activity required to his suited to the body of that particular individual or in general, we must have to design the transportation system or the material handling system as per that. It is called as ergonomic principle. Energy principle: include energy consumption. You must utilize minimum energies for transportation of material. So this is called as energy principle. Ecology principle: minimize adverse effect on the environment. While you design the material handling system, you must have to see that it is environment friendly. Mechanization principle: mechanize the handling to increase the efficiency and economy and easiness to the human being or any other guy. Flexibility principle: use methods and equipment that perform a variety of tasks. This is called as flexibility principle. Anybody, any device can transport any device. It can transport any part, which is called as flexible principle. Simplification principle: simplify handling by eliminating reducing or combining unnecessary movements and equipment. Gravity principle: use gravity to move materials among the various resources or machines that are available on the shop floor. Safety principle: provide safety and safe material handling equipment and methods and practices. Computerization principle: consider the computerization of material transportation system, and the AGVs are one of the automated or computerized material handling systems. System flow principle: integrate data flow and with physical flow of material or goods or whatever it is. Layout principle: prepare an operational sequence and equipment layout for ease and economy of transfer of materials among the various resources on the shop floor. Cost principle: economy effective. Maintenance principle: prepare a plan for preventive maintenance and scheduled repairs so that it's ease of maintenance and increase the reliability of material handling equipment. Obsolescence principle: identify longer lasting equipment available on the shop floor for material handling system and identify the equipment that is giving frequent troubles based on the previous statistical records, and prepare a long range plan and economically replace the equipment as an obsolescence. So this is called as obsolescence principle. You have to design the material handling system based applying the above discussed principles for the movement of materials and other parts in a manufacturing process or a warehouse facilities affects directly the plant output. Material transportation is achieved by various means. One is industrial trucks, automated guided vehicles, monorails, rail guided vehicles, conveyors, cranes and hoists. Though the material transportation is achieved by various means, our subject of discussion is only on the automated guided vehicle. What is this automated guided vehicle, which is popularly known as AGVs? Let us just discuss a brief history of AGV first, then go to the principles of AGV and other things. The first AGV was developed by A.M. Barrett in 1953. In 1973, Volvo, the Swedish car maker, developed AGVs to serve as assembly platforms for moving car bodies through its final assembly plants. Car bodies are continuously under movement. While the body is moving, the operations are performed. This is particularly in the final stage of assembly. This is done. At the end of the assembly, the car is rolled out of the factory. The car is rolled out of the factory. Completely assembled car is rolled out of the factory. The body is being put on an automated guided vehicle, and the guided vehicle is moving in a desired path from one end to the other end. And while it is moving from one end to the other end, the other operations are the other assembly operations which will be done on the car body will be normally done, like fitting of doors, fitting of tires, etc. are done when it is moving. It is used in Volvo during 1970s, and it was one of the successful applications of AGV. Advances in AGV's technology have been motivated largely by rapid developments in electronics and computer technologies. Automated guided vehicles were developed as a result of our VLSI and other computer programming and computer technology that paved the way for the development of advanced AGV systems. You see in this slide, we can have the first AGV is 1953, and the first Tugger unit is 1959. First assembly vehicle developed and used in Volvo in 1973, and first unit load vehicle AGV was developed in 1976. The 1973 Volvo in Kamar, Sweden, utilized 280 computer controlled AGVs instead of using the typical conveyor and assembly line. You can see this is that. This figure contains several AGVs are moving, carrying the automobile part. In 1953, first AGV is created, and you can see the AGV created in this diagram as well. First unit load AGV was developed in 1976. You can see this unit load AGV, first unit load AGV, now used for many different applications in multiple setting of industries. It is very popular AGV being used widely, and you can see that it is developed in 1976. Then 1985 single wire guidance AGV was developed, and 1989 PC controlled based controller AGV was developed in 1989, and 87 also laser guided AGV was developed, and 1991 inertial guidance or inertially guided vehicle has been developed, and wireless AGV system has been developed since 1992, and 2003 onwards the AGVs or advanced AGVs are pathless AGVs, changeable path. It can change the path in an autonomous way. That was the latest development in AGV systems. Let us see the definition of an automated guided vehicle. An AGV system is a material handling system that uses independently operated self-propelled vehicles guided along the defined paths. What is a good use for AGVs? Whenever repetitive motions are existing, repetitively the material is to be transported over distances of 150 and more, and multiple shift operations, the AGVs are best. Desire to save costs and improve efficiency, these are all the reasons motivated for the development of the automated guided vehicle system. Why use automated guided vehicles? Not a permanent obstacle, and paths can be changed easily. System can be expandable easily. Does not represent a single point of failure. System has built-in redundancy. Favorable cost benefits compared to other automated material handling systems or solutions. Because of that, the AGVs got popularity. The certain advantages or the pros of AGVs are as follows. No building modification is required. Existing building can be as it is used. If you take overhead cranes we need to structurally modify the existing building. You cannot directly use overhead crane. Whereas AGV can be used with the existing facility without change of that. How the normally human beings use the path in a factory, the same path can be used as a path of AGV. Additional AGVs can be added at any time. Any number of AGVs can use the same path. However, it may lead to certain conflict problems or traffic control problems. Those can be avoided by means of certain control principles and certain control algorithms. Path is flexible and easy to modify. You can develop the entire AGV network plan, and the path in which the AGV can be moved, that path only can be activated. The remaining path can be made infeasible. So AGVs can choose the path which is activated. Thus, AGV path can be changed easily and flexibly. Software simplifies future expansion, integrates with WMS, provides continuous service throughout. It increases the throughput, would require additional vehicles, because when throughput increases, number of vehicles are demanded more. Technical support and skills must be developed and continuously updated. The feasibility of AGVs, it saves labor hours, allow flexibility of changing of path and routes. It saves floor space. What is in an AGV system for this, particularly for controlling? You can see in this slide, it is an RF principle being used here. It's a wireless terminal. The sensors that are mounted generate RF radio frequency, and the radio frequency LAN is there, local area network, and that receives these signals and send it to the host computer, and the host computer in turn will process and communicate to RF modems, and the signals from the RF modems will be given to the vehicles or supporting equipment about the movement of the vehicle or where exactly it is. That's how it's basically important important operation of an AGV. Let us discuss the important components of an AGV. The components of an AGV is the vehicle. The vehicle is a mechanically structured vehicle containing several structural elements made up of cast iron or weldment structures, and it is used to move the material. It should be less weight. The weight consideration is this should be as less weight as possible so that it can take more payload. Second component is guided path. The path is to be set. AGV path is to be preset. It guides the vehicle to move along the path. And the control unit, it monitors the direct system operations, including feedback on moves, inventory and vehicle status. Computer interface, it interfaces with other computer systems. Particularly, it has to have an interface with the supervisory computer that is available on the shop floor. The supervisory computer is also controlling the machines and other secondary material handling devices. The supervisory computer will call for an AGV when a particular component is machined on a particular machine. The supervisory computer will give signal to AGV to go to that and direct it to go to that particular machine to receive the component. Similarly, it also directs the AGV containing the component to the next machine where the part is to be further machined. Like that, the computer on the shop floor is controlling, and the AGV is necessarily to be communicated with this machine, with this computer. We have several AGVs being used or developed. The types of AGVs are towing vehicle, unit load transporter, pallet truck, forklift truck, light load transporter, assembly line vehicle. You can see all these types of things here. It's a towing vehicle here, and a unit load vehicle, pallet truck, forklift, and light load AGV, and assembly line kind of AGV you can see in this figure. It was the first type of AGVs to be introduced and still in use. This is the towing vehicle. The towing vehicle is commonly used in moving heavy payloads over large distances in warehouses or factories, with or without intermediate pickup and drop-off points along the route. Normally, in a flexible manufacturing system, this towing vehicle cannot be used, whereas in a system where warehouses are there, big lump of masses have to be moved from one point to the other point covering a long range of distances. Automated towing vehicles are used. It is an efficient type of transportation system there. You can see this application of towing vehicle from any point to any point. Once the entire load is packed in at one point, it can transport that entire thing. It is towing is not like a towing of a vehicle. It can be towed to any place where it is supposed to be kept. You can see this is another big towing vehicle, and you can see three big banks of work pieces, or the cotton looms are being transported in a big spinning mill. Pallet trucks. Pallet trucks, these are used to move palletized loads along predetermined routes. You can see it here. And AGV pallet truck, you can see it here. It is self-explanatory, not necessary to be discussed much on that. AGV pallet trucks, the truck is loaded automatically or manually. The load can be elevated slightly, then the worker drives the truck in a specified path. The capacity ranges up to several thousands kilometers, and some trucks are capable of handling 2 pallets rather than 1. The recent one is forklift type AGV. The significance of this is it has vertical movement of its forks to reach loads on racks and shelves. You can see the application of pallet truck in this figure. Unit load containers. These are used to move unit loads from one station to other. They are often equipped for automatic loading and unloading of pallets by means of powered rollers, belts, etc. Light load unit containers are relatively small vehicle with corresponding light load capacity of 500 pounds or less. An assembly line AGV is designed to carry a partially completed sub-assembly through a sequence of assembly workstations to build the product. You can see the unit load carrier. This is the real picture of an unit load carrier. Vehicle type unit load carriers that are used in various manufacturing systems. Various enterprises, you can see them. This is an application of an AGV unit load carrier in a typical environment. Forklift truck. The forklift truck has the ability to pick up and drop off palletized loads both at floors and on stands. They can also stack loads in racks equipped with sensors so there is no need of human operator. Expensive AGVs, so they are applied only in the system where fully automation is required. Limited to palletized loads with ability to different height facilities. You can see the forklifters here. This is outrigger straddle type forklifter, and this is side reach type forklifter, and this is the reach forklifter. And there are other things: counterbalance forklifter, fork overflow forklifter, and narrow agile forklifter. Application of forklifter in a typical manufacturing environment, you can see in this figure. Light load transporters. Next variety is light load transporter. This capacity is less than 500 pounds, used to handle small light parts over a moderate distances, designed to operate with limited spaces. And the typical application of light load transporter is this, and particularly in a typical manufacturing environment, how easy it is used, you can witness it from this figure. Assembly line vehicles, which carries major sub-assemblies, provides manufacturing flexibility by permitting parallel operations in manufacturing processes. Whenever we use AGVs are called as asynchronous material transportation devices. Why? It doesn't require any sequence of things, because one AGV is moving part from one machine to the other machine, another AGV can move part from other machine to the another machine. So these two are independently operated, and that's why this is called as asynchronous material handling device. And that's how it provides flexibility, manufacturing flexibility, by permitting parallel operations in the manufacturing processes. Low, expensive and easy to install. Variable speeds and dwell intervals can be programmed. Expensive planning is required, and speed is in the range of 100 to 200 feet per minute. Capacity is 500 to 2000 lbs. The latest variety of AGV is self-guided vehicle. The self-guided vehicle is with the AGV of advanced technology. It uses a combination of dead reckoning and beacons located throughout the plant, which are identified by onboard sensors. What is this dead reckoning? Dead reckoning is nothing but capability of a vehicle to follow a given route in the absence of the defined path and the floor. Beacons are the standard positions located strategically throughout the plant. Some systems use magnetic beacons throughout the plants. These beacons give signal, and based upon the beacon positions and other things, the self-guided vehicle decides the route and follow the route accordingly. You can see this is a self-guided vehicle, and another self-guided vehicle is this. Now let us now discuss the management of AGVs. What is the management? Management is the guidance, the routing, AGV control system, and interfacing with other subsystems. Let us now decide or discuss about AGV's guidance systems. AGV guidance system is to keep the vehicle in the pre-designated path. Type of guidance systems are wire guidance system. An energized wire is embedded in the floor along the AGV guide path. If the wire is energized, that energized wire gives a path, gives a guidance to the vehicle to follow the path. Optical guidance system. Colorless fluorescent particles are painted or taped on the carpeted or tiled or concrete floor, and this AGV follow this and as a guidance path, guided path, and this is called as optical guidance system. Inertial guidance system. An onboard microprocessor is used to steer the vehicle on the programmed path. A preset or programmed path is defined, and the onboard microcontroller will be continuously giving signal to the AGV guidance system. This is called as inertial guidance system. Infrared guidance system. This system consists of infrared light transmitters, reflectors mounted in the roof of the facility to reflect the lights. Next is laser guidance system. A laser beam is used to scan wall mounted barcoded reflectors, and which provide as the guidance to the AGV. Teaching type guidance system. In this system, neural network concepts are used. Neuro fuzzy systems are also used, which will give a neuro path that follows. In the teaching type guidance system, neural network concepts are used. Laser guided layout. You can see in this figure how laser guidance is given for the AGVT to follow a particular path. Thing is that how the AGVs are steered, which is also called as steering control. Control the vehicle to negotiate a turn and to maneuver physically in different ways is AGV steering control. Types of steering controls are differential speed steering control, which uses an amplitude detection type of guidance sensor, and steered wheels steer control, which uses a phase detection type of guidance sensor. How AGV routing is fixed? A sensor detects the magnetic flux carried by the wire in the channel and follow the corresponding path. Thus, the two principal methods of taking the decisions are frequency select method, where the path is based on the appropriate frequency; path switch method, switching off the circuit which are not in use takes place in this type. The wires must be perfectly insulated. You have to take care of that. Types of AGV's control systems are computer control system, remote dispatch control system, manual control system. You see here, this is a typical AGV control system where it is a computer control system, and this computer will go on sending signals to the AGV to follow a particular path. Computer control system. You see this in this path, in this we have a controller for guided path and the AGV processor, controller and host computer and input terminal, and we have a display terminal. In this AGV process controller gets signal from the input terminal and also from the host computer, and it process the route and give it to the path controller. The path controller will move, the AGV will move according to the guided path, and the path is being also displayed in the display terminal. Remote dispatch control system. Human operator is required to issue instruction to the vehicle through a remote control station. Human operator will call the vehicle by voice, or human operator will give a signal to the vehicle to start from a remote place. And control system sends the distinction instructions directly to the vehicle. Most of them have automatic loading and unloading capability. Manual control system. Operator loads the vehicle and enters a destination into the onboard control panel on the vehicle. The vehicle is routed by itself to the designated through the guide path. Wait for unloading. It's a simple and least expensive of all the control systems. Interface with other subsystems. Automated guided vehicle should have interface with automated storage and retrieval systems, and if it is in a flexible manufacturing system, AGV is a part of FMS, and it should have to have interface with the machine control units, machines and robots that are being used as secondary material handling transportation devices, CNC machines, process control equipment, shop floor control system, etc. AGV load transfer. The loading and unloading of AGV's vehicle is also known as AGV's load transfer. Types of load transfers are manually load transfer or automatic load and unloading. How AGVs are powered? Normally AGVs are battery operated. Thus, standard charging unit is required for charging the battery. In vehicle, when the vehicle is also moving, the battery sometimes gets charging, and inductive charging principle can also be employed. AGV design features, special features unique to the AGVs such as stopping accuracy, facilities, safety, maintenance. System design of AGVs. System design of AGVs include the selection of guide path type and vehicle type, flow path design, guide path layout, type of flow path within the layout, know and location of load transfer points and load transfer station storage, number of vehicles required. They are all this part of this. Number of vehicles required can be derived by this. Let us say D, small d, is total average load travel distance, and DE is total average empty travel distance, and NDC is equal to number of deliveries required per hour. TH is loading and unloading time. TT is traffic factor. V is vehicle speed. Then total time per delivery per vehicle is TDV, which is equal to DD by V plus TH plus DE by V. Number of deliveries per vehicle per hour, ND, is equal to 60 TF by TDV. Number of AGVs are NDR divided by ND, where ND is equal to 60 TF by TDV. Safety is very important feature of an AGV. Traveling speed should be slower than walking speed of a human being. That's how it's one of the safety features. Obstacle detection sensors are there on board of the AGV. Thus, any human being passed across the AGV waits for some time till the passage of the human being and then go or follow the path. Obstacle detection is done. Obstacle, sometimes avoidance is also being done. Warning bells. It gives whenever AGV is moving. During that path, it gives warning bells or warning lights with blinkers. A bumper is provided in front of AGV, which when touches an obstacle, it stops automatically because of the predetermined program. So the bumper, it won't dash us, it just a feather touch is just sufficient to stop the bumper, give detection to the AGV to stop there. You see, one of the safest feature in this, you have for this vehicle, you have front and rear bumpers, and the vehicle speed is 100 to 300 feet per minute. The sides are optical bumpers are also available. Here in this vehicle, we have optical tower protection, an electronic protection group, front warning zone is there, front stop zone is there, side protection, rear warning and stop zones are all the features, safety features are included in this vehicle. You can see some of the applications of AGVs in practically. This is one application of assembly where AGVs are used in the assembly stations. In battlefield, unmanned vehicles, AGVs are used as unmanned vehicles in battlefields to carry on certain arms and to identify certain unexploded bombs to pick up from the warfield, and so on and so on, to identify the wounded soldiers and to safely bring this wounded soldier from the unidentified warfields. Hospital materials, to transport the hospital materials including patients, we can use AGVs. Hybrid AGVs which can be used for transfer of different materials. And you can see this as a Mars rover vehicle which is used on the Mars, and it is an AGV, popular AGV. Military shooting range tuggers. These are all also remotely operated guided vehicles. Monster AGVs, you can see these AGVs which can be used to transport vehicles and heavy weight components, etc. Paper roll metal coil industries. AGVs are used to transport the loads, paper loads, big bundles of paper, paper bundles or paper rollers can be transported using these vehicles. People movers, okay, this AGV where people can be transported from one point to other point. Applications and manufacturing sectors involves raw material handling, assembly line, flexible manufacturing technology, WIP movement, pallet handling, finished product handling, tooling movement, roll handling, delivery of supplies, custom application AGVs, storage and distribution. The limitations of AGVs include high cost, flexible routing, non-obstacle pathways. Which this ends the lecture, and thank you very much for your patient hearing. So dear friends, in this lecture we have learned so many things about AGVs. Automated guided vehicles or unmanned vehicles, their applications not only in manufacturing sector but also in various public sectors and various other fields of engineering. How the guided vehicles are used, we have discussed. We also seen the classification of the AGVs and different types of AGVs, and each type of AGV where it is used, and the guidance of AGV, path control, steer control of AGVs, and the command control of AGVs, and the several design aspects of AGVs, like the vehicles, number of vehicles required in a typical traffic intensity, how we can calculate the number of vehicles, and other things we have discussed. So with this knowledge, I am pretty sure that in a given manufacturing environment, in a given SIM environment, computer integrated manufacturing environment, when the path is given, how to use an AGV and where to locate the loading and unloading points, how to control the traffic of AGVs and number of AGVs required, I am pretty well sure that you are in a position to do that. Thank you very much.